All right. Determine whether the function shown is continuous over the interval -6 to 6. And clearly the answer is no for two reasons. Number one, the 2 points on the graph are not connected. And number two, even if they were connected, there's an open circle here at the point 1, 2. So for those two reasons, this is not continuous. You have to pick up the pencil several times. Determine whether the function is continuous over the interval -6, 6. And again, the answer is no. And that's for one reason. Despite the fact that the 2 points are connected at 3, 0, there's a problem. When x is 4, you see that there's an open circle at y = 1, and you have to pick up the pencil. For that reason, it is not continuous. Next, we are going to use the graph to find the following limits and function value. So first, we're going to find the limit when x approaches 1 from the left. So when we're approaching 1 from the left, that means the part of the graph that is on the left side of 1, when x = 1, the y is going to be equal to 5. But what if we approach it from the right? Well, if we approach it from the right, then the y is equal to 1. So then what if we were to approach 1 head on? Well, the limit does not exist here, because if we were to approach from the left, we get 5. But if we approach from the right, we get 1. That's inconsistent, and as we know, 5 never equals 1. So therefore, the limit doesn't exist. So now the function value, f of 1. The answer is going to be 5 rather than 1, because at 5 there's an open circle, and at 1 there isn't. So at 5 there is a closed circle, and then at 1 there is an open circle. That's why f of 1 is equal to 5. Next up, use the graph and the function to find the following. Find the limit of k of x as x approaches 3, find the function value, and then determine whether or not this is continuous. So the limit as x approaches 3 here is going to be -2. That is the y value, the y coordinate. Then we are going to determine the function value. And as you see here, the function value is undefined at x = 3. Now, why is that? It's because at x = 3, at the -2 for y, there's an open circle here. If the circle was closed, then the answer would be -2. Is k continuous at x = 3? The answer is no, because at x = 3, there is an open circle here. So for that reason, it is not continuous, as we had to pick up the pencil once we reached x = 3 and then y = -2 before we continue the graph. Next up, we are going to find the limit as x approaches 4 from the right and 4 from the left. If we look at 4 from the right, which is this point right here, you're going to see that x = 1, 2, 3, 4, 5. But if we approach from the left, you will see that y is equal to 2. Therefore, for B, if we approach 4 head on, you will see that there is a disconnect here. And therefore, because of this disconnect between the two y coordinates, then the limit does not exist. So then, for the function value, the f of 4, is it 2 or is it 5? Or is it undefined? The answer is 2, because at y = 2, there is a closed circle. rather than an open circle at y equals 5. So then we got to answer the question on whether or not f of x is continuous at 4, at x equals 4, and explain why or why not. And the answer is no. And the reason is because at x equals 4, the limit of x approaching 4 does not exist. And the reason for this is because, again, if we approach on the left, we get one thing, and if we approach on the right, we get something different. Therefore, no limit, and that's why it is not continuous. Is the function given below continuous at x equals 3? Why or why not? So we have our f of x equals to 7x minus 3. If we were to put this into the calculator and graph it, what you're going to see is a straight line that is continuous with no open circles. And so for that reason, the answer is yes. F of x is continuous at x equals 3 because the limit as x approaches 3, f of x is equal to f of 3. That's why it exists. So then for number 17, the question here is, if this is continuous at x equals 4, and for the f of x, the two functions that we are dealing with are going to be 1/4 x plus 3 and then 2x minus 4. The first one is going to be for when x is less than or equal to 4, and the second one is going to be for when x is greater than 4. So what I'm going to do is stop share for now and switch over to my iPad via AirPlay, and we will determine once and for all if this is continuous or not. Don't mind the answer, just imagine what the process is like to determine whether this is continuous or not. So let's give that a whirl. All right, so now let's give this a go. So on the left side, we have 1/4 x plus 3 equals to 2x minus 4. So at x equals 4, we are going to plug in the 4 right here into the equation, and we will determine whether these two sides match. So 1/4 times 4 equals 1, then we add a 3, then 2 times 4 equals 8 minus 4, so then 1 plus 3 is 4, 8 minus 4 is 4, they match up, this is good. So the answer to whether or not this is continuous based on the work shown is yes, it is. And the reason for that is because at f of 4, the f of 4 equals to the limit as x approaches 4, and f of x equals to 4. So essentially, because when we put the equations on opposite sides and plugged in 4 of x, and it gave us a match of 4, for that reason, it is continuous. Now, what about for number 18? Well, for number 18, we have, for g of x, we have x squared minus 16 over x minus 4 for when x equals anything except for 4, and then 8 for when x is equal to 4. So for this one, what we're going to do again is we are going to do AirPlay on my iPad, so give me a minute to set that up again. All right, so now just like in number 17, we are going to put the equations on opposite sides of the equal sign. So what we're going to do for the x squared minus 16 is we're going to break this up into x minus 4 times x plus 4. So when we plug in the 4, so first off, we see an x minus 4 and an x plus 4, and we're going to imagine that this is an imaginary 1. So these x minus 4s will cancel, okay? So then we have x plus 4, and that equals to 8. So when we plug in this 4 right here, when x equals 4, you will see that 4 plus 4, that equals 8. And therefore, through the work shown, we can see that this is indeed continuous. Is the function given by g of x equal to 1 over x plus 4 continuous over the interval -3-3 y or y not? And to put it simply, the answer is yes. And the reason it's yes is because if we were to plug in -3 as x, we'd have -3 plus 4, which equals to 1, which is not undefined. So yes, the function is continuous over -3, 3, because g of x is a rational function and the values over the interval -3, 3 are in the domain of g. If this was -4, 4, or -4 something else, the answer would be no, because this would be undefined. So is the function given by g of x equal to square root of x minus 11 continuous over the interval 11 to infinity, y or y not? The answer is yes. So any number that is 11 or greater is going to be a positive square root, which is not going to be undefined. That's why it is continuous. Any number smaller than 11, and that makes this not continuous, because negative radicals will have to be converted into a fraction, which does not make sense. As for the last problem here, it says that the candy factory sells candy by the pound, charging $1.75 per pound for quantities up to and including 25 pounds. Above 25 pounds, the factory charges $101.60 per pound quantity plus a quantity surcharge K. If X represents the number of pounds, the price function is as follows. So for the P of X, we have 1.75x for when X is less than or equal to 25 pounds. Anything greater, and it will be 1.60x plus K, and that is for when X is greater than 25. So now again, for the last time in this lesson, I'm going to share screen on my iPad via AirPlay so you can see the work that I'm doing. Okay, so let's put 1.75x on the left and then 1.60x plus k on the right. So we're going to do 1.75k, plug in the 25 there, then 1.60k, or not k, x, yeah. So 1.60, and we're going to substitute the x for 25, and then have k there. So if you take out your calculator and do 1.75 times 25, you will see that that is 43.75. Then 1.6 times 25, that equals 40. So then if we subtract 40 from both sides, that leaves us with 3.75 is equal to k, which is the answer for number 21. That is going to do it for section 1.2.